Hello. Today we are going to be going through the answers for the Chapter 2 review. So on the first one, we have a number y is no more than negative 23. Well, if it's no more, it has to be smaller. So I already see something that I want to change on that one. If it, I read it too quickly. I read it as more than. So if it's no more, it has to be smaller than. All right, for the second one, 3 times a number p is fewer than 25. So 3 times a number p would be 3p. Fewer than would be a less than, and there's your 25. On number 3, the sum of 6 and a number q is at least 12. Well, if it's at least 12, it can be bigger than or equal to 12. Number 4, I think the hardest part there is 4 times the difference of 10 and a number m. So you have to subtract and then multiply that by 4 times that difference is at most 16. So if it's at most 16, that's as big as it can be. It can be smaller. All right, on these ones, we're going to be solving them. So first thing on this one, it's 12 times. I need to do the opposite, so I'm going to divide both sides by 12. And if I take 156 divided by 12, I'm going to get 13. And there's a negative there, so I get x is greater than or equal to negative 13. Put negative 13 in the middle. Do something smaller. Do something larger. And that's going to be a closed dot at negative 13. Shaded to the right. I don't flip the direction because I'm dividing by a positive 12. On number 6, though, I've got negative 3 halves. And I'm going to multiply by that reciprocal, which is negative 2 thirds. A number times its reciprocal cancels out. So I'm left with y. And I have to flip the direction. And if you're a little iffy on your fractions, negative 2 thirds times 27 over 1, I can cancel. And I end up with a negative 18. I'm going to rewrite it so that my variable comes first. It's pointing to the y, needs to still be pointing to the y. So negative 18 in the center. Something a little smaller. Something a little bigger. In this case, it's going to be an open dot shaded to the left. On number 7, remember 2 positives. You add the opposite. Think of that as plus m. You're going to then do the opposite. I have a minus 16, so I need to add 16. Oops, forgot my 1 there. And I get m is less than or equal to 28. I'm going to put 28 in the center. A little bigger, a little smaller. Closed dot at negative 28. Shaded to the left. All right, on this one, I want to write an inequality. Well, it's everything smaller than negative 1, but not including negative 1. So my description, everything smaller, but not including negative 1. On a test, I'd be looking for the smaller, but I'd also be whether or not negative 1 is included. If it were a filled in dot, then it would be including. It's an open dot, so it's not including. All right, here we're going to be solving a problem. So we're going to start with the original problem. Actually, I used the distributive property. So I guess I probably should have changed that to distributive. I did not write the original problem down, and I probably should have. But what I started with was just distributing that -6. And I already see a little bit of a bonehead mistake. So I'm just going to start over on this problem. And that's okay. That happens from time to time, where you notice a mistake and it's not that big of a deal as long as you correct it. Whoa. Let's try that again. So I use my distributive property, and I'm left with 3w minus 12 is greater than or equal to -24w plus 6. I think I was going too fast last time, and I didn't take that 4 into consideration. So now I want to get all my variables to one side, so I'm going to add 24w to both sides. And when I do that, I'm going to get 27w minus 12 is greater than or equal to 6. Well, now my variables are on one side. I need to get my numbers to the other side. So I'm going to add 12 to both sides. And when I do that, I get 27w is greater than or equal to 18. Well, that w is still not by itself, so now I need to divide by 27. And when I do that, I'm going to get w is greater than or equal to 18 over 27. And I'm going to reduce. And when I do that, I get w is greater than or equal to 2/3. And I want to leave that as a fraction. And sometimes we get fractions as answers. It's okay. On number 10, here's my variable, x. I want to get that x by itself, so I have a -12 who's bothering it. I need to do the opposite, add 12. Need to do it in the center, to the left, and to the right. And when I do that, I get -15 less than or equal to x less than 34. So I'm not going to do all the hash marks here. -15, +34. It would be a closed dot at -15, open dot at 34, and it's shaded in between. I can tell it's in between because that x is in between those two numbers. 11, I have to solve each of those problems separately. So I'm going to think of that as one problem, and then I'm going to think of that as another problem. So let's go ahead. Our variables are on one side. I'm going to get my numbers to the other side. So add 3, and I get 2x is less than or equal to 0. I'm going to go ahead and divide by 2. Oops. Let's move that up a little. Divide by 2. And I get x is less than or equal to 0. Now I need to solve this one over here, so I'm going to -4. And when I do that, I get -3x is less than -12. I'm going to be dividing by -3. And when I do that, I need to flip the direction of that inequality sign, and I get 4. And this has a separated by the word or. So when I see that word or, I'm thinking opposite directions. So I'm going to graph that separately. I'd have a closed dot at 0, and that one's going to shade to the left because it's pointing to the left. Here, that would be an open dot, and it's going to shade to the right because it's pointing to the right. On 17, what I need to do on that one is set up 2 inequalities. But before I do that, I have to get that absolute value by itself. So I'm going to go ahead and plus 1 to both sides. When I plus 1, those cancel out, and I'm left with 2x, or the absolute value of 2x plus 13 is less than 17. Once I have that absolute value by itself, I can set up 2 equations. I have the negative scenario and the positive scenario. On the negative scenario, I flip the direction of the inequality. So that less than becomes a greater than. I started with a less than, and I should put the word and in between. I can leave it like this, but the better way to do it is negative 15 is less than x is less than 2. So all I did was I rewrote those as 1. So I'm going to shade in between negative 15, and again, I'm not going to do all the hash marks. It's going to be an open dot and shaded in between. Remember, less than, you connect with the word and. Greater, you connect with the word or. So on number 13, I'm connecting it with the word or, and that absolute value is already by itself. So y plus 7 is, do the negative scenario, less than or equal to negative 13. You flip the direction for the negative scenario, and I get y is less than or equal to negative 10. All I did there was I subtracted 7 from both sides. So when I graph this one, negative 10, closed dot, and it's pointing to the left, so I shade to the left. Closed dot at negative 4, shade to the right. Let's take a look at number 14. On that one, the latest iPhone costs $1,150. Evan currently has $900 saved from his job. He earns $20 each time he rakes leaves. So each time he rakes leaves, I'm going to call that R. So I just defined my variable. I want to write and solve the inequality to find out how many times Evan needs to rake his leaves in order to buy the new phone. Well, when I did this, he's starting with $900. So we have $900 to start with. And he's increasing it by $20 for each raking job. So $20 times R. He can make more money than $1,150. But he needs to make at least that amount. So it can be bigger or equal to. So I'm just going to start then by subtracting 900. And when I do that, I'm going to get 20. R is greater than or equal to 250. Divide by 20. And R has to be greater than or equal to, if I do that, I'm going to get 250 divided by 20 is going to be 12.5. But if you take a second and really thinking about it, you can't have half a rake. So if I were going to answer this, I would answer it as Evan needs to rake at least 13 lawns. Because if he only rakes 12, he's going to be a little bit shy. If he rakes 13, he'll make it the money that he needs to buy that phone. All right. Hope you enjoyed. If you have any questions, there is Math Lab available 5 to 7.